Dear all, thanks for joining this webinar. My name is Marian Langevoort, and together with my colleague Jaap Steketee, I prepared a presentation about the application of municipal solid waste incinerator bottom ash in the Netherlands. I will tell you something about the regulation of the applications, the type of applications, and in the end I will present a case study of a work we did in Appingedam, which is in the northern part of the Netherlands. First, I will tell something about TAO, which is the organization we are working for. TAO is an European environmental consultancy firm, which has offices mainly in the western part of Europe. We have offices in the Netherlands, Germany, Belgium, France, Italy, and Spain. Here is a selection of our expertises, which is covering a broad spectrum of services. All have a connection with the living environment. Our mission is to contribute to a safe and sustainable environment. With our dedicated and competent people, we shape a vital living environment by providing impactful solutions and combining strong expertise with valuable partnerships. So that's why our slogan is, it's not just a daily job, but it's a living ambition. First, I will tell you something about the regulation of the application of municipal solid waste incinerator bottom ash. The first regulation originates from 1986. It was a guideline how to apply bottom ash. It was very loosely formulated, loose regulations. So over the years, the regulations became more specified and more strictly formulated on which requirements application needed to be fulfilled. Because there is already a long history of legislation, we have all in the Netherlands a long history of application of bottom ash. So it is applied as a building material for more than 25 years on already. In the period between 1997 and 2021, municipal solid waste incinerator bottom ash was applied in almost all cases as a isolation, control and maintenance building material, which means that there were requirements on the isolation of the bottom ash within the applications, and there was a continuous obligatory to control and maintain these requirements of the application. This resulted in application of about roughly 30 million ton of bottom ash, of which about 6 million was applied in highways in this construction of ICM building material. So the practical experience with these applications were generally speaking good, but there were some problems mainly with the liners and with the groundwater level, where the requirements were not always fulfilled. The liabilities and the everlasting monitoring and maintenance made that it was not very attractive for owners for construction to make new ICM building material applications. And so with the years, the people were not that enthusiastic anymore to make new applications. That's why in 2021, with the, of course, there was already longer speaking about a Green Deal, and this Green Deal made was an agreement between the companies in the market and the government that there was a transition of bottom ash made into a free applicable building material. So they said in 2017, 50% of the bottom ash should fulfill this capabilities. And in 2020, 100% of the bottom ash should be applicable, free applicable building material. Next to the applicability of the bottom ash, there was also an agreement that there should be more metals recovered from the bottom ash within this Green Deal. So then I come to the applications. What kind of type of applications there are used in the Netherlands? So most of the bottom ash is applied in embankments. You can think of noise barriers, embankments for flyovers, bridges, large volumes of where large volumes of bottom ash can be stored. Another application is application as an additive in products, especially for partial replacement of gravel or sand in certain concrete products. Another application is an application after immobilization by adding a cement-like material. These products are used in foundations for solar farms, roads, large industrial sites. I will show you some examples of these different types of applications in the coming slides. I want to emphasize that in the Netherlands, it's prohibited to landfill bottom ash, but it can be applied as building material in a landfill, especially as a support layer for the liner constructions. Now, we have made an inventory of the type of applications of bottom ash in the Netherlands. This inventory was done for the period between 1986 and 2018. We were able to locate about more than 400 locations where bottom ash was applied. Especially from the beginning period, it was not always clear how much bottom ash was applied, and we were able to, from about 330 locations to get information on how much bottom ash was applied. We made a theoretical consideration on how much bottom ash could have been applied in this period in the Netherlands, and it was about 38 million ton. The total amount of bottom ash applied in these 330 verified locations was about 31 million ton. So we conclude that if we compare those numbers, and we were missing the information about the application on the amount of bottom ash for 90 locations. So if we conclude that we didn't miss large amounts of bottom ash, and that this missing information can account for the difference between the total amount of bottom ash we have verified and the theoretical amount of bottom ash that has been applied in this period. So for the period until 2004, we also made an inventory on the type of applications, and then we saw that about 35% was applied in embankments, about 27% was used in the foundation for business parks, 18% was applied as building material on a landfill, and 2% was used for other type of applications. It would be interesting to see with the new Green Deal and the new legislation how these type of applications vary and what the current status would be. Here I show you some examples of applications. This is an example of an embankment of a noise barrier along a highway. The highway is actually on the other side of the noise barrier, so you cannot see the highway at this picture. But what you can see is that the construction of the isolation measures that are taken. The bottom mesh is underneath this foil you can see here. So the bottom mesh is completely covered with foil, and on top of the foil a soil layer is applied, and on the sides this soil layer also needs to fulfill certain permeability values and measures. A second very similar example, which is an embankment for the flyover at Highway 6 in the Netherlands, which is visible here. Actually, this embankment is already in place, so this is how it looks like when everything is ready. Another example of an application of bottom mesh in the Netherlands, which is shown here. This is a mixture of bottom ash with rubble granulate, which is used for roads. And here they are working on the construction of the road. Another example of application of bottom ash, which is a picture from pavements. Here the gravel is partially replaced by bottom ash, which you can see on this picture of this concrete pavement. Last example I'm showing you is application of bottom mesh after mobilization. So in this area just above the two red boats you see on this picture, they are working on the installation of a new pavement, and this pavement is made out of partly out of bottom ash. So they first immobilize the bottom ash, and it's applied in this layer of this industrial site. Then I'm going to the case study. The N33 is a provincial road which contains two lanes where traffic can drive, and there are plans to broaden the highway to 4 lanes. So they're going to reconstruct the road. Near Appingedam, which is close to these curves in the road, there is an embankment to a bridge, and this bridge is going across the Eems channel. And in these embankments, bottom ash is applied. Well, because they are going to reconstruct the road, there is a question on what they have to do with this bottom ash, which is applied. The embankments were constructed in the period of 1989 and 1990, and about 150 tons of bottom ash was placed in these embankments. Well, what were the objectives to study this application? In case they need to reconstruct the road, they need to know what the quality of the bottom ash was, environmentally, but also civil technically, because they needed to know if they had to what the options were to for the bottom ash, where they had to go. There was also insight needed in the application options when this bottom ash would become available during the reconstruction works. And next to that, they wanted to know the quality of the top soil layer, such that they could judge if this layer could be reused. They also would like to determine if the soil underneath the bottom ash was influenced and if the groundwater quality was influenced, because in case they decided that the bottom ash could stay in place, they needed to know this information. And also for the reconstruction works they were planning, there was a quantification needed if natural solidification had occurred. So in order to investigate these objectives, we have performed an investigation. I'm showing here a cross-section of the embankment. This embankment was placed there around 1990. So at that point, there was not very strict legislation. They made a construction where the bottom ash was inside the embankment, which on top was a sand layer, and they put a foil on top of this sand layer. Then they made a construction layer and the highway. At the sides, they placed a top layer of soil. We investigated the quality of the bottom ash by drilling in between the cycling path and the highway. So by drilling at this point, and we took samples from the bottom ash and also from the underlying ground. And next to that, we also sampled the top layer of the sand at the sides, and we also excavated at the toe of the application to sample even more bottom ash, so which is around here. I'm showing some pictures of the fieldwork we have performed. So here is a picture of the liner, which is taken through the application, and on the right side you see the excavator, which we see. This is a picture taken inside the hole, the digged hole, and you see here that the foil is really present and still closed. This is a picture from the sampling in the slope of the application. You see here the bottom ash and all the samples we took. Here I am showing results from the analysis we've performed from different layers from the bottom ash. So here on the left axis, you see the concentration of chloride, and on the right you see the pH. We mixed different samples into different layers. So the first, we have layers from 1 to 6, which represent bottom ash layers in the application, where layer 1 is at the top and layer 6 is at the bottom of the bottom ash. So we see for chloride, which is this yellow-blue line, we see that the chloride decreased in the top layers and the concentration increased more in the bottom layers. For pH, we see a similar effect. We see that the pH is relatively low in the top layer with about 9.5. This indicates that weathering had occurred by a reaction of CO2 from the atmosphere or from the soil. And this last part you see in the layers more in the center of the application, the pH of the bottom ash is higher. And for the lowest layer, we see that the pH is a bit lower than inside. And this is probably due to the reaction with CO2 from the soil. So weathering of bottom ash results in general improvement of the quality as metals are fixed. So this is not valid for sulfate and antimony. I will show that in the next slide. Here you have the emissions determined in a column experiment. We see here that chloride, sulfate, antimony, copper, and molybdenum have emissions on the norms for the isolation control and monitoring applications. This more strict norm is for free applicable bottom ash. So you see that some parameters are even fulfill this more stricter norm, but only the parameters I just mentioned, they are not. We see that the emission of antimony is relatively high, and we see that the bottom ash is weathered, and also we see that the leaching of salts occurred as this chloride concentrations are relatively low. We've also performed an anaerobic column experiments because field measurements indicate that anaerobic conditions were present in the bankment. We conclude that the results are comparable with the standard aerobic column experiment. However, the emissions of chloride, fluoride, antimony, copper, and selenium are lower because in anaerobic conditions, these elements are more bound in the system. We also investigated the civil technical quality of the bottom ash. Also for this and also for the previous slides I showed, for this specific application, we don't have the information about the quality of the bottom ash at the moment it was applied. So we can only compare it with the general expectations we have from the quality of bottom ash at that time frame. So if we compare it now with the standards, we see that for the civil technical quality of the bottom ash, it still fulfills the requirements for application of this bottom ash. We also investigated the quality of the groundwater and the quality of the underlying soil. For the groundwater quality was measured in various monitoring wells. So chloride, arsenic, and molybdenum were detected in concentrations higher than the threshold values, but there was no trend visible in time. And these parameters were also high in the reference monitoring well. And on the other hand, typical parameters for bottom ash as copper and antimony were not detected in elevated concentrations. So also for the soil underneath the municipal solid waste incinerator bottom ash, we concluded that low levels of mercury, zinc, and copper were shown in some samples, but there was also no clear relation with leaching of bottom ash visible. So to conclude, we have investigated this application of bottom ash near Appingedam. We determined the quality of the bottom ash, and after 30 years of use, the bottom ash is still can still be seen as the and has still the quality of a isolation, control, and monitoring building material. Leaching of antimony has probably occurred. Also, the civil technical parameters were still very similar as the ones we have expected. And also, within this application period, no big changes occurred in quality, and it can be applied in a similar way. We have no clear observation that there was contamination in the surrounding environment. We also had a goal to see if natural solidification had occurred. We conclude that it probably will not give big problems if part of the bottom ash is removed. Probably also the inner part of the embankment is more solidified than the outer part, and we have sampled both inner and outer parts, but we think the solidification was reasonable. The pH of the bottom ash, especially in the outer parts of the applications, is relatively low, and this indicates that the bottom ash is weathered and partly carbonated. Leaching of chloride probably occurred. The clay liner in the slopes is not sufficiently watertight, but I have to mention here that there was also in the legislation no requirement on how watertight that layer should be. So with this research, we've gained insight in the properties of the bottom ash, and this information is important for the client and the contractor to further scope their plans. They can prepare their work and make cost estimates. I would like to thank you for your attention, and I'm looking forward to your questions, and I'm happy to answer them.